everyone. Note 6.1 are on similar triangles. And up here it says triangles that have identical angles and side lengths are called congruent triangles. So, for example, if you have this triangle right here, triangle ABC, and then we have triangle DEF, we would say that if A is congruent to angle D, if angle B is congruent to angle E, angle C is congruent to angle F, and side length AB is congruent to DE, side length BC is congruent to EF, and side length AC is congruent to DF, then these triangles are congruent. So the way we would write this is triangle ABC is congruent to triangle DEF. Okay. However, if we have triangles that have identical angles, so the same exact thing about the angles, but the sides are proportional and not equal, these are called similar triangles. So, for example, let's draw this up here. If I've got triangle ABC and then here I've got triangle DEF, they still would have the identical angles. So the angles are still the same size. So that means that angle A would be congruent to angle D, angle B would still be congruent to angle E, angle C would be congruent to angle F. But if you notice, DEF is larger than ABC, so they don't have congruent side lengths. So what we would say here is triangle ABC is similar to triangle DEF. So this symbol right here means similar. So it says to graph the following triangles on graph paper, labeling each vertex with the correct letter. So for starters, we've got this is 0. We've got our x-axis here, a y-axis there. I'm going to go by ones for each one of these, but I'm not going to label every single one. It's up to you. If you want to label, go for it. And I'm going to draw out triangle ABC with one color. So A is at 2, 1. So here's A. B is at 6, 1. And C is at 2, 4. So we'll call this A, B, C. Here's my triangle right here. And then I also have triangle DEF, so I'll do that in a different color. And the coordinates for triangle DEF are 5, 5, 13, 5, and 5, 11. So here's D, here is E, and here's F. And I'm going to connect these dots. And then it says shade each triangle lightly with a pencil so that you can see each clearly. Here's one triangle right here, and then here's my other triangle right here. Okay, so now we want to fill in the table using the graph above. So angle A right here, which by the way is a right angle, angle A would be congruent to angle D. Okay, so here we would say that angle A is congruent to angle D. Okay, and we also know that angle B is going to be congruent to angle E. And we know that angle C is going to be congruent to angle F right here. So we know our angles are going to be congruent. Now let's look at our sides. So let's figure out all these different side lengths. So the first one we have here is AB. So I want to figure out how long AB is. So AB, I could use the distance formula, but I don't really need to because I can just count since it's on a horizontal. So 1, 2, 3, 4. This gives me 4. Now let's count how big DE is. So 1, 2, 3, 4, 5, 6, 7, 8. So right here, this has a ratio of 1 to 2. Okay, this reduces to 1/2. Let's do the same thing for AC. So here's AC, this is 3. This is DF, 1, 2, 3, 4, 5, 6. So 3 over 6, when I reduce that, is also 1/2. Now for BC, I actually have to do some work to figure out how big BC is right here. So I have two options. I could either use the distance formula to figure out how big BC is, right here by just plugging it into the distance formula right here, or I could do Pythagorean theorem. I'm going to use Pythagorean theorem because I already know this is 3, this is 4, so I'm going to figure out what this is. So I'm just going to do 3 squared plus 4 squared equals x squared. So here 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. Square root both sides, I get 5. So here I know that BC is going to be 5. I want to do the same thing for EF. Same thing, I could use distance formula or Pythagorean theorem. Since I know these are 6 and 8, I can just say 6 squared plus 8 squared equals let's use c squared here. So I'd say 36 plus 64 equals c squared. This gives me 100, which means that c has to be 10. So here, this has a ratio of 5 to 10, which reduces to 1 to 2. So here, the ratio is 1 to 2. Okay? So here it says the ratio that you have found is called the scale factor. So this is your scale factor. Okay? And this is just a conclusion of everything that we've learned so far. A, B, C, and D, E, F are called similar triangles. When triangles are similar, it means two things. The first thing it means is that the ratios of lengths of corresponding sides are proportional. And then the other thing that it means is that corresponding angles will always be congruent. And another word for congruent just means that they are equal. All right, so it says which triangles are not similar to the other three, and explain. So if you take a look right here, in our first triangle right here, the angle A is 35. Here, angle J is 32. So one of these doesn't fit. Angle D is 35. Angle G is 35. So the one that doesn't seem quite right is the blue one. Let's look at the other one. So let's compare. So 82 will correspond with 82, which will correspond with 82. Those are all equal to each other right here. Sorry, we should mark this off with 2 to indicate that it is a different angle. That is different than the angle up here that's 85. Okay, and even though all four of these have 63 degrees, even the blue triangle, it doesn't work. The blue triangle is the one that does not fit because all three of your angles have to be congruent in all of your triangles. So we can say that triangle JKL is not similar. Okay, and this right here is just a little note that you can look at on your own. Just talks about corresponding sides and corresponding angles. Okay, all right, so the next question here says, show that these triangles are similar. So right here, and then it says start by assigning a letter to each vertex. So for this first triangle right here, I'll call this triangle ABC. For this next triangle right here, I'll call this triangle XYZ or XYZ. And if you look right here, we know that angle B is congruent to angle Y. We know that angle Z is congruent to angle C, and we know that angle A is congruent to angle X. We can say that angle B is congruent to angle Y, angle C is congruent to angle Z, and angle A is congruent to angle X. So this right here will tell us that the two triangles are similar. So a triangle ABC is similar to triangle XYZ. But we can also use the sides, which means right here that AB is going to be, so here I would say it's proportional to XY. We also know that BC, this side length right here, is proportional to YZ. So here I'm going to say BC is proportional to YZ. And we also know that AC is going to be proportional to XE, or at least we think so, right? So let's show that they're similar. So let's fill in the information that we have here. So we know here that AB is 6, that BC is 4, and that AC is 8. So here, instead of AB, I'm going to say 6, BC is 4, AC is 8. We also know in the other triangle that XY is 9, YZ is 6, and that XZ is 12. Okay, and if I were to reduce all of these, I would end up getting 2/3, 2/3, and 2/3. So we can also say the sides are proportional. Therefore, triangle ABC is similar to triangle XYZ. Okay? So I want you to write up here that there are a couple of ways that we can use to prove similar triangles. There's 3 different ways, but I'm going to only talk about 2 different ways. So to prove similarity, we have angle-angle similarity. So right here, AA means angle, angle. Or we could also do side-side-side similarity. So SSS means side-side-side. One quick note about angle-angle similarity is that we only need 2 angles right here because in a triangle, if 2 of the angles are congruent, then the third one has to be congruent because the angles add up to 180. Okay, so here we can say triangle ABC is congruent to triangle XYZ by angle-angle similarity, and here we can say by side-side-side similarity right here. Okay. All right, so let's take a look at our next example. What is the scale factor from triangle EFG? So here we can see that the triangles are similar because they have at least 2 congruent angles, and then by default, the third angle will also be congruent. So here we can say that triangle EFG is similar to triangle ABD by angle-angle similarity. Okay, and this symbol right here means similarity. Okay, so we know that they are similar, which means that the sides are proportional. So here, what is the scale factor? Well, we know side EF in this triangle and its corresponding side is 4. So the scale factor would be 28 to 4, or 28 over 4, which ends up being 7 to 1, or 7 over 1, or 7. So we can use that information to help us find out the length of GF. So we want to find this length right here. So there are 2 different ways to do this. The first method is to use your scale factor. So, and by the way, I will write SF a lot. That stands for scale factor. So here we know that this side length corresponds to BD, which is 5. So I can just take 5, multiply that by 7, which is my scale factor, and I get 35. So we can say that it is 35 centimeters. Another way is to write a proportion. So let's talk about what a proportion will look like. So if I were to do a proportion here, I know the 2 sides that I know are 4 is proportional to 28. So right here, what I would say is I would put the 4 on top, the 28 on the bottom, or vice versa, it doesn't matter. And that's going to equal over here, on this side over here, we've got side 5, and we want to use that to figure out what this missing side is right here, so we'll call this x. And to be able to solve a proportion, we cross multiply. So 4 times x is 4x. 28 times 5 is 140. Divide both sides by 4 and you get 35. So either way, you'll get 35 centimeters. Okay? All right, in example number 3, it says these are 2 similar triangles. We want to find the length of x. So we know that they're 2 similar triangles. If it didn't tell us this right here, we would still know that they're 2 similar triangles because we've got 2 congruent angles, or 1 set of congruent angles here because they're 90 degrees. But we also have these opposite angles as well. So those are also congruent to each other. So this angle is congruent to this angle, and then my right angles are congruent, so they're similar by angle-angle similarity. Okay? So here's the thing though. If you notice right here, side length x is my hypotenuse, which means that's going to correspond to the hypotenuse right here. Okay? And then I also know that this side that connects the angle that the opposite angle to the right angle will be proportional to this side that connects the opposite angle to the right angle. And then we also know that this side length would be proportional to this side length. So if I were to set up a proportion to figure this out, the ones that I know are the 20 and the 12. Those are a match because I know that those are corresponding sides right here. And I'm trying to figure out this x, which means I need to use 25. 25 would have to go on top because 20 and 25 are in the same triangle. And here, these have to, if I put 20 on top here, then I have to put 25 on top here. And then here, the x goes on the bottom. The x and the 12 would also go hand in hand. Okay, so if I were to cross multiply this right here, I would get 20x, cross multiply this right here, and I would end up getting 300. Divide both sides by 20, and I get x equals 15. So here the side length is 15. I also just want to say really quickly that if you choose instead, when you set up your proportion, to say that this is going to be 20 on top, and I'm going to use the 25 in the same triangle. I want to put the two sides that are in the same side triangle in the same proportion. That's totally fine. So then that means that for the other triangle that I would use the side that corresponds to the 20 on top, which is this 12, and then the side that I want to know is the x corresponds to the 25, so I'd put that on the bottom because 25 is on the bottom here. Either way, you would still cross multiply 20 by x, you still get 20x, and then 25 times 12 would still give you 300, which means that you would get 15. Okay, that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.